This program is made possible in part by Michigan Department of Education, the State of Michigan, and by viewers like you.
Week of summer with the Michigan Learning Channel. Welcome. We are so glad you could join us. If you've been with us for 8 weeks, thank you for giving us your time. If this is your first time here, we're excited to have you. The information we talk about today and resources for you that are free can be found at michiganlearning.org/summer. Once you go to that site, you will find you can download this book for free. This is a fun activity book for pre-K through second grade. And then we've also got a fun activity book for third through sixth grade there. You can download any of the weeks, any of the grades, anything you're interested in. It's all free right at michiganlearning.org. But wait, we are in the last week of summer for the Michigan Learning Channel, but we're not done here because this is a channel that is here to stay. So check back here when you get time to see what we've got planned for fall. But today we are in Space Week, and I am super excited to introduce you to my friend Sierra. That rhymes with Tara because I'm Tara Hardy, the Director of Education for the Michigan Learning Channel. Sierra comes to us from the Michigan Science Center, and she is under the stars today. Welcome, Sierra.
Hello, Tara. Thank you so much for the introduction.
Absolutely. What have you got for us to do today?
So today we're going to strap into a virtual planetarium, and I'll actually be giving you a tour of the night sky. So the things I'll be showing you guys today are things that you can actually see in your very own backyard if you go out tonight. So we're going to transition into our virtual planetarium. So I want everyone at home to do is to go ahead and put on their imaginary seatbelts, okay? So chuck in, okay? Let me hear that clicking noise, that click. That means your virtual seatbelt is on. And we're going to move into our planetarium. So right now, we are looking at the sky, how it looks right now if you go outside. Well, maybe not right now in Detroit because it's very, very rainy, unfortunately. But if we had clear skies, it'd look a little bit like this. So the very, very bright object that we're all looking at right now is the closest star to us. It's, of course, our very own sun. So we're looking at our daytime sun. And unfortunately, when our daytime star is out, that means we can't actually see a whole lot of other stars. That's because the sun is so much closer to us than all of these other stars, it appears a lot brighter. In fact, it's so bright that it drowns out the light from all of the other stars. What that means is that in order for us to see some more stars in our night sky, we have to move forward in time. Because our virtual planetarium isn't just used for looking at the sky, it's actually also a time machine. So right now, I am making us go forward in time. I'll be trying not to go forward in time too fast. I don't want us all to get time vertigo. But I am going to speed up the movement of the sun. So right now, our sun is moving from the east to the west. And right now, it's being joined by a companion. I'm actually going to stop moving forward in time so we can check out our friend over here. So this is something that we're all familiar with. We all know and love. It's our very own moon. So if we zoom in on the moon, we can get a closer look as to what phase it's in. So it might be a little surprising to some of us. I know we usually think of the moon as something that we can see at night, but actually we can see the moon during the day too. It all just depends on what phase the moon is in. So right now, our moon is in a waxing crescent phase. So the waxing means that it's going to be appearing to get bigger and bigger in the sky. So over time, as we go through the weeks, it's going to start appearing more and more full. The crescent is just in its shape right now. So right now it looks kind of like a crescent roll like that you might have at dinner. So that's why we call it a waxing crescent moon. So if you keep an eye on the moon, it'll appear to get fuller and fuller in the sky. So I'm going to zoom us back out now. And we're going to go back to moving forward in time. All right, so right now we are facing our southern sky. That's what this big red S means. And our sun is going to continue its journey from the east to the west. So because right now we're in summer, that means the sun takes a pretty long path across the sky. Depending on what season we're in, the sun moves in slightly different paths. For example, during the winter, it'd be a lot lower in the sky, so our sun would be making a path like this. And because we're in the summer, we're a lot higher in the sky. In the spring and in the fall, it's in the middle, so not too low and not too high. Right now, our sun is starting to set in the west, which means we're getting that beautiful sunset. And then as soon as our sun dips below the horizon, we get a nice view of our night sky. All right, so I think this is a good time to stop. Now, because we're in the summer, it takes a lot longer for the sun to set. So that means you have to wait a little bit later at night in order to get a dark night sky. Right now, we're looking at a sky at roughly 11:30 at night. I think the sun starts to set between 9 and 10 right now, so around 9. So usually by 10, you might be able to see some stars, but this is the best time, around 11:30 p.m. So I'm going to move our view around. We're actually going to face the northern sky because we're going to start by looking at some northern constellations. Now, constellations is a very, very long word, a very fancy sounding word. It basically means shapes that we can see in the sky. So since basically the dawn of time, as long as people have been looking up at the sky, they've been trying to see images out of them. And this is a shared cultural heritage that we all have here on planet Earth. So we're going to be looking at some different star pictures that are the same thing that people saw thousands, hundreds of years ago and all across the globe. Now, the very first star picture I'm going to be looking at is something that you guys are actually probably familiar with at home. In fact, if you know this star picture, you can go ahead and throw it in the chat. But this star picture is made up of 7 bright stars in our northern sky. In fact, I can zoom in just a little bit here. So these 7 stars right over here in our northern sky, a little bit northwest right now. So like I said, it's made up of 7 stars. 1, 2, 3, 4, 5, 6, 7. And if we draw some imaginary lines between them and use the power of our imagination, it starts to look like a shape. Now, I don't know about you guys, but to me, this looks like a big cup. So here we have the handle of the cup. And here we have the actual cup part, the little bowl part they use to scoop things out. And in fact, this gathering of stars is called the Big Dipper. So I'm sure a lot of you guys have heard of the Big Dipper before. And it's not just well known because it's relatively bright and easy to find in the night sky, but it actually helps point us to one of the most important stars in the sky. So if I take these 2 stars that make up the edge of the cup of the Big Dipper, and I draw a straight imaginary line between them, I end up at this bright star right here. Now, does anyone have a guess as to what this star is? I'll give you a hint. It's directly above this giant letter N, okay? So we have a very, very bright star that's so important that we have a special way to find it. And it's directly above our giant letter N. So this star is actually our North Star. So it got that name because it's directly pointing north. Now, here's the thing about the sky. Everything in the sky appears to move. The stars at night, the sun during the day, the moon, everything appears to move except for the North Star. That's what makes it so important. So if you're ever getting lost trying to navigate at night, all you need to do is find our North Star and you would know what direction north is. That's what makes it so useful. Now, the North Star is also part of its very own constellation. So just like the Big Dipper, this is made up of 7 stars, but they're slightly dimmer than the Big Dipper. So this one will be a little bit more difficult to find on your own. In order to find it, I recommend starting at our North Star and then looking for these 2 brighter stars in a straight line. So if we go from the North Star and we make an arc to these 2 brighter stars in a straight line, that gives us the general shape of our next star picture, which is called the Little Dipper. I'm actually going to draw some imaginary lines between the Little Dipper so you guys can see it a little bit more clearly. All right, so here we have our Little Dipper. And as you can see, just like with our Big Dipper, we have our handle and we have our bowl, and that gives us a big floating cup in the sky. Now I'm going to do the same thing with our Big Dipper, okay? I'm going to draw some imaginary lines between it, but it's going to look a little bit different than our Little Dipper. Let's see why. So here we have our Big Dipper, and when I draw on our imaginary lines, it actually looks kind of funky. It no longer looks like a big floating cup in the sky to me. There's a bunch of extra stars tacked on to our Big Dipper. Now the reason that is the Big Dipper itself on its own is not actually a constellation. So there are 88 official constellations that are used today by the International Astronomical Union, and their job is basically to break up the sky into a bunch of different puzzle pieces. The Big Dipper and the Little Dipper are not officially constellations, but they're something we call asterisms. So asterisms are just things that we can recognize in the sky. So really common star pictures, basically. Now I have a question for you guys. Looking at our extended Big Dipper, this really, really weird kind of funky shape, does anyone have a guess as to what this image might be of? Or even just looking at it, what does this image look like to you guys? So if you have any guesses, you can go ahead and throw it on into the chat. I'll give you guys a moment to think about it. I like to think about it too. I look at this image really frequently and it always looks like something different to me every single time I look at it.
Sierra, we have one guess of a monkey.
A monkey. You know what? I've actually never heard that one before, but I like it a lot. This definitely kind of looks like the tail of a monkey, right? And maybe it's kind of like on all fours. I like that a lot. What do you think, Tara? Any guesses? What does this shape look like to you?
I was thinking some sort of animal with a tail up.
Okay, cool.
You see like a little mouth down there at the front?
Over here. This is the little mouth of the animal. I like that a lot. That's really good. Sometimes I like to think it looks kind of like a giraffe, where these are like the giraffe's legs, and this is its really long neck. But all very, very good answers. I tend to get a lot of animals. I get a lot of maybe horses or dogs. Now, officially, this constellation is supposed to be of a bear.
Oh, we also had a deer as an idea there.
Ooh, a deer is another really good guess. I like that one a lot. I think it's actually a little bit better than what it's officially supposed to be. Because I know when I look at this, I don't see a bear, right? So this is supposed to be our big bear, and this is supposed to be our little bear. And it's probably a little hard to imagine right now. But what I want us all to do at home is to use our powers of imagination and see if maybe we can get a bear to appear on that screen, okay? So imagine as hard as you can. Keep imagining. Let's see, and there we go. Okay, so here's our two bears, but you know what? It actually still doesn't really look like a bear to me. There's something very, very strange about these bears. I don't know if you guys have ever seen a bear before, maybe at the zoo or on TV, but they actually tend to have very short, kind of stubby looking tails. Our bears up here have these really long, kind of magnificent flowing tails. And there's actually a reason for why that is. Now, not only do we have constellations we can see up in the night sky, they often come with stories behind them as well. So we've been telling stories about the sky for as long as humans have been around. Astronomy is actually the oldest living science. And the story for our two bears, whose names are Ursa Major and Ursa Minor, goes a little bit like this, and I'll tell an abridged version. But our two bears were wandering around in the woods one day in ancient Greece when they came across the Greek god of thunder and lightning named Zeus. And this is very, very important thing to know about Greek mythology. Zeus is not a very nice guy. Generally, you don't want to get to know him. And Zeus was in a bad mood for some reason or another, so he actually grabs these two bears by their tails and swings them around really, really fast and then throws them into the night sky. And when he did that, he stretched out their tails like silly putty or mozzarella sticks. So that's why they have these really long, stretched out tails. Now, maybe that sounds kind of sad. Maybe you're feeling a little bit bad for two bears, but don't worry. These bears are actually a mother and a baby bear. And now they circumpolar constellations. They get that name because they circle our polar star. In fact, I can go forward in time a little bit so you guys can see what this looks like. So right now, as we go forward in time, everything in the night sky is appearing to move, just like I said earlier, while the North Star is staying in place. And in fact, it starts to look like our bears actually circle our polar star.
It looks like we might be having a little trouble hearing Sierra right now. I'm going to, there, now we can.
All right, testing. Can you guys hear me okay?
Yeah, now we can. That was weird. You went away for a minute. So we didn't hear what you said after the twirling the bears around by their tails. The mother bear and the baby bear were okay. Oh, I think we still lost you. Yeah, we still aren't hearing you, Sierra. Those of you at home, as you're watching and we try to get this fixed up, I would love to have you put some stuff in the chat about why you think the mama bear and the baby bear were okay after they were swung around by Zeus.
Are you guys able to hear me a little bit clearer now? What about now?
Yes.
Okay, excellent. All right, so we'll keep.
Oh, we lost you again. The joys of doing live performances when we're in the middle of storms and floods and electricity going out. Bear with us as we continue to go. I think we'll probably get past the bears a little bit here.
Yes.
There we go.
Can you guys hear me a little better now? Testing. Can you guys hear me okay? Awesome. Okay, so I'm going to switch to my handheld mic for the duration of this program. Hopefully that won't get in the way too much, and as long as you guys can hear me, that's totally fine. Let's go back to talking about our bears. I know you guys were at the edge of your seats wondering what happened to our two bears. Well, after they were picked up and thrown into the night sky by Zeus, they were placed in the sky to live together forever. And like I said, I think that's kind of like a happy ending for our two bears, because Ursa Major, which means big bear, and Ursa Minor, which means little bear, now get to spend the rest of eternity together up in the night sky, because they're actually a mother and a baby bear. So I think things worked out pretty well for them, so don't worry about them too much, and now you can see them all year round. I'll repeat what I just said about circumpolar constellations, just in case you guys didn't hear me the first time. But circumpolar constellations are constellations you can see no matter what time of year it is, or what season it is. That's because everything in the night sky swirls around the North Star. Like I said, the North Star doesn't appear to move. That's because of the way the Earth's axis is tilted. Actually, the North Pole, so the very tippy part of the Earth, is pointed directly towards our North Star. What that means is that as the Earth spins on its axis, everything in the night sky will appear to move except for the North Star. So that's why you can see our two bears all year round, no matter what season it's in. So now we're going to change gears a little bit, and we're actually going to check out some seasonal constellations. These are constellations that do change depending on what time of year it is. So in order to see seasonal constellations, we have to move away from our North Star. I'm actually going to put our bears away for now. And we're going to go ahead and we're going to check out our southern sky. So you can usually see our seasonal constellations in the south. So I'm slowly turning the sky. And when you guys are actually looking for this constellation on your own tonight, the way I recommend finding it is going outside and looking directly up. So look directly up and look for the brightest star that you can see. So now we're facing our southern sky. Like I said, I'm going to tilt our screen upwards so we're facing directly towards the middle of the sky. And when we do that, we can see 3 bright stars. Now, the brightest of the stars that you'll be able to see is this star right here called Vega. And Vega is incredibly bright. In fact, it's the 5th brightest star in the night sky. Now, a lot of us believe, or maybe have heard before, that the North Star is the brightest star in the sky, but that's not the case at all. The North Star is closer to the 50th brightest star in the sky. So it's actually very, very dim compared to the stars we're going to be looking at now. So these three stars make up another asterism. And this asterism is called the summer triangle. So how this works is that we draw some imaginary lines between our three stars here, Vega, Deneb, and Altair, and it makes a big triangle up in the sky. Now, the cool thing about the summer triangle is that each star in the summer triangle actually has its very own corresponding constellation. So what we're going to do now is we're going to play my favorite game, which is the Summer Triangle Guessing Game, in which we go to each constellation in the Summer Triangle and we guess what we think the constellation is supposed to be up. Are you ready for a challenge, Tara?
I am so ready for this.
Awesome. Okay, that means we're going to start with the hardest one, okay? So we're going to start with Vega. So I'm going to bring up Vega's constellation. I'm going to let you guys think about it for a little bit. And I want you to tell me what you think this constellation is supposed to be of. And I'll zoom in on it a little bit so you can see it a little bit clearer.
So all right, for Vega, we're looking at the line and then kind of like a parallelogram there.
Exactly, yeah. Basically a line connected to a parallelogram. So very, very abstract. Any guesses as to what you think this constellation is supposed to be of?
Those of you at home, we'd love to see your guesses in the chat, and I will read them here. I'm guessing that's the base of something.
Ooh.
Maybe like a pyramid with a tail?
A pyramid with a tail. I like that one a lot.
Oh, we got a kite. We've got a kite from the audience.
That's excellent. I actually hear kite a lot, so that's a really, really good one.
It does look like a kite.
I see a kite. One that I get frequently is tie, actually. Does anyone maybe at home also see a tie?
Oh, like a tie that a gentleman would wear?
Yeah, like a necktie.
Necktie. No, I don't see that.
Well, you'd have to be tilted on your side a little bit there.
Oh, I see. It's like the little, okay. And it's not very long. I see what you're saying.
Yeah, very short kind of tie. So we have tie, we have the base of something, we have a pyramid with a tail, we have kite, all very, very good answers. Now the Greeks, when they saw this parallelogram connected to a line, thought to themselves, wow, you know what this looks like? A harp. So, yeah.
Harp. Oh.
To be honest, a lot of the times they're kind of a stretch. I'm going to be honest, I think the kite was a lot closer to what this looks like than a harp. But officially, the Greeks saw a harp, or a lyre, to be more accurate. So that's the first one. That one was really, really difficult, so it's okay if we didn't get it at home. Let's try another one. Let's try one that's a little bit easier. All right, so I'm going to bring down the art for our harp, which is called Lyra. And we're going to take a look at our next constellation, which is Deneb. All right, so just like before, I'm going to bring up the constellation, and then I want you guys at home to make a guess as to what you think this constellation is of. All right, so a lot bigger than what we saw with our last constellation, Lyra.
Oh, is it maybe like a starfish?
A starfish. That is such a good answer. I actually like that one a lot. Good guess. I can give a couple of hints for this one, okay?
We've got a trident.
A trident, another very, very good one. I'm loving where your guys' heads are at.
Oh yeah, we gotta think like Greek gods here.
Yes, exactly. So try to put your head in the minds of the Greek astronomers, okay? So what are things like the Greeks love playing instruments? That's why we had our lyre. Let's think of other things that might have been around back then as well.
A sword?
A sword? Ooh, that is such a good guess. Right, where this could be like the sword, the length of the blade. We have its hilt.
Oh yeah.
Very, very good.
Pull it out of the rock there.
Okay, these are all such excellent guesses. So I'll give you guys one hint. This is actually of an animal.
Oh.
So an animal with a long neck and then also a pretty impressive wingspan.
Oh, is it a flying, like a dragon?
Dragon's a really good guess. I like that one a lot. There is a dragon in the night sky. Not here, though.
Maybe it's a pterodactyl?
The pterodactyl. I think the Greeks were big fans of pterodactyls. I like that answer. So officially, this is actually of a swan. So here we have our swan named Cygnus. So like I said, Cygnus has a long neck and pretty impressive wingspans. But the coolest thing about Cygnus is actually where Cygnus is located in the night sky. So if I zoom out a little bit more, you guys might be able to tell on your screens back home that Cygnus is flying along this brighter patch of sky. Are you guys able to see that, this brighter patch of sky?
Yeah, a little bit.
Okay, cool. It's a little bit dim, and it's something that we wouldn't be able to see in a really bright city like Detroit. This would be something you'd have to go very, very dark, someplace very dark to see. But what we're actually looking at right now is the Milky Way Galaxy. So the Milky Way is the galaxy that we all live in, right? All of the planets in the solar system, all of the stars we can see in the night sky are all a part of the Milky Way. And if you go someplace very, very dark, you can basically see the outer bands of the Milky Way. So that's what we're looking at right here in our virtual planetarium. So even though we can't see the outline of the Milky Way in a busy city like Detroit, we can see Cygnus. So if you're able to find Cygnus in the night sky, you're able to tell where the Milky Way is.
How do we tell the difference between a planet and a star?
That is such a good question. Thank you, Tara. So the difference between a planet and a star is actually in their appearance. So you might have heard the song before, Twinkle, Twinkle, Little Star. Well, that's because stars in the night sky tend to twinkle. Basically, they shimmer, they flicker in and out of light. Planets, on the other hand, don't do that twinkling motion. They're a pretty constant source of light. So later in the show, if we have some planets up, I'll actually show you guys some planets up close. But when you're looking for them tonight in the night sky, just look for some bright objects that aren't flickering. And that's how you can tell the difference between a planet and a star. That's a great question. All right, so going back to our summer triangle, I'm going to bring down the art for Cygnus the Swan and Lyra the Harp. And we're going to look at the last star in our summer triangle. So the last star is this one over here called Altair. So just like before, I'm going to bring up its constellation. I'm going to give you guys a couple of moments, and I want you to guess as to what you think this shape is of. All right, so here we go. All right, so for the last round of our summer triangle guessing game, what does the shape look like to you guys?
I'm going to guess a dragon because it's very similar. What I've noticed about these is I'm always looking at it a different way than when you show it. So I'm trying to look at it like it's flying down.
Ooh, I like that a lot. You're right in that this one looks really similar to the last constellation. That was a really good observation.
We have another guess of a sword. It also looks like a sword.
It also looks like a sword. There are definitely swords up here in the night sky. So these are really, really good guesses.
It looks a little bit like an airplane too.
I like that. Yeah, an airplane. What I like to do is like connect these lines here. So I fully connect them, and I think it looks kind of like a manta ray.
Oh yeah, we also got a sea star.
A sea star, excellent. So we're both thinking of marine animals. That's awesome. All right, so a lot of people have pointed out about how this one looks really, really similar to the last constellation we saw. And you guys are totally right. This is actually another bird. So just like before, how we saw Cygnus the swan, this one is actually of Aquila the eagle. So you guys are totally right in seeing wings. Yeah. Like what you said with an airplane, we can see those wings really, really clearly. All right, so if we zoom out, we can see our entire summer triangle, which is basically two birds and an instrument. Now, the summer triangle is, as you guys might be able to guess by its name, is something you can only really see well in the summer. So that means as it starts getting colder out, which will happen eventually, hopefully, these constellations will start dipping below the horizon earlier and earlier. So we might not be able to see them for too much longer. So definitely check out the summer triangle while you guys still have a chance. All right, so we're doing pretty good on time. So I'm actually going to show you guys a couple more constellations. So we're going to actually look, let's see. I went forward in time a little bit earlier. So I'm going to go ahead. We're going to move a little bit backwards in time. We're going to go back to about 11:30 at night so we can see another constellation that's really prevalent in the summer. All right, so here we go. So we're at about 11:30. I'm going to go ahead and I'm going to bring down our summer triangle constellation so they don't distract us for this one. And I'm going to draw our attention to this object right over here in the southern part of our sky. Now, I'm really, really glad that you brought up the question between the difference between planets and stars, because the next object we're looking at is really, really commonly confused for a planet. In fact, it got so commonly confused for a planet back in the days that the Greeks gave it a very special name. So this bright object right here, as you guys might be able to read, is called Antares, and it's a very, very bright red star. In fact, it's so bright and red that people always confused it to be the planet Mars. So in order to get rid of that confusion, they named it Antares. Aries means Mars, and Ant means not. So this star is literally just named not Mars. Now, all of the stars in the night sky are not Mars, but this star is not Mars in particular. And this star, Antares, is also part of its very own constellation. I'm going to bring it up. And even though we're not doing our summer triangle guessing game, I'm still very interested. What does the shape look like to you guys?
Oh, I see a snake.
A snake. That's a very, very good one. I definitely can see a snake.
Oh, we also got a claw.
A claw. I like that one a lot.
Some sort of like serpent or something.
Serpent, you're very, very close. So this actually goes by different names throughout different cultures. So we call this constellation Scorpio. So you're very, very close thinking of a snake or a serpent. So we definitely have that long kind of spindly tail. This is actually one of the constellations in our zodiac as well. But depending on where you are on the Earth, it's not always called Scorpio. Some of you guys might have seen the movie Moana before. Tara, have you ever seen Moana?
I've seen pieces of it. I haven't seen it. My kids are teenagers now.
Well, you should watch it when you have the chance. It's a very, very cute movie. But in Moana, what they're trying to do is they're following a hook in the sky, and that's where they're getting their directions. Now, in Polynesian cultures, this is actually Maui's hook. So while we may call it Scorpio, this constellation is also called Maui's hook, the same that you'd see in the movie Moana. All right, so since we had a lot of time looking at different constellations and we got to see a lot of stars, let's switch gears for a little bit. Let's actually try to find some planets. Now, in our virtual planetarium, the stars aren't twinkling like they would be if you see them outside at night. But we have other ways to find our planets, luckily here. And in fact, these two bright objects that you can see in front of you are two planets. So if you go outside tonight, look in our southeastern sky, look for two bright objects that aren't flickering, you should be able to find our two planets. I'm going to bring up their names. So here we're actually looking at Saturn and Jupiter. So these objects are very, very bright. Now, not all planets are going to be brighter than the stars around them, but a lot of the times looking for a bright object would be a pretty good way to find a planet. Let's look at these planets a little bit closer. So let's start with Saturn. And I'm going to show you guys an image of what they might look like if you saw them for, for example, a telescope. So I'm zooming in closer and closer and closer to Saturn. And now we're getting a nice clear image of them. All right, so when Saturn was first observed through a telescope for the very first time, it was described as being a planet with ears. So picture something that looks kind of like Mickey Mouse, because they couldn't exactly tell the difference between the rings and the planet itself. So luckily, the telescopes we have today are a little bit better than the ones they used back then, and you're able to see the rings around Saturn pretty clearly. Now, from a distance, these rings look solid, but they're actually not solid at all. In fact, they're composed of tiny, tiny rocks that range from the size of a small pebble to an SUV. So these big rocks, they all orbit around Saturn, kind of like mini moons. And that's why they look like rings from a distance. All right, so let's leave Saturn behind Let's go ahead and visit the other planet pretty close by, which is the planet Jupiter. Jupiter is one of the brightest things that you can see in the sky. So the brightest thing you can see in the nighttime sky is, of course, the moon. It's followed by the planet Venus, which is very, very bright. And then we have the planet Jupiter. Now, Venus is very bright because it's pretty close to the Earth. Jupiter, on the other hand, is bright because it's very, very big. In fact, it's the largest planet in the solar system. So let's go ahead and take a closer look. So these objects that you can see around Jupiter right now are actually moons. So these are called the 4 Galilean moons. And they got that name because they were discovered by Galileo himself. Let's get a little bit closer to Jupiter. Both Jupiter and Saturn have a lot more moons than we do. While we may have just the one big moon with the big capital M, Jupiter and Saturn each have over 60. I think Saturn's at 82 moons right now, in counting, because we're always finding more. Now, earlier I was talking about how Jupiter is the largest planet in the solar system. To give you guys some perspective, this dot right here, which is called the Great Red Spot, is actually a storm that's been going on Jupiter's surface for hundreds of years. And the entirety of the Earth can fit inside of this storm. So that's how big Jupiter is. And that's why we're able to see it, even though we're very, very far away from it. All right, so.
At PBS Kids, we call our moon Luna.
Luna, yeah, exactly right. The moon has a lot of different names in different cultures. Luna is Spanish for moon. You can also call the sun Sol if you want, which is Spanish for sun. So now you guys had a chance to see some of the different stars and constellations that you'd be able to find in your very own backyard tonight. Now I have one quick demo to do before I let you guys go. But before we move on to our demo, do I have any questions about what I talked about so far today? About the stars or about the constellations that we looked at?
Yes, you said, well, I know that you said it's hard to see stuff in Detroit because of the lights. And you said 11:30 p.m. is a good time to see a lot of this stuff. Are there places to go? Should we be higher up on top of buildings, or like what's an ideal way to see the sky?
That is such a great question. So being higher up on top of buildings is a good idea. So basically what's good about that is that you won't have a lot of images obscuring your view. So what that does is clear your horizon. However, the best way to see more stars is actually to go to someplace very, very dark. So a city like Detroit has a lot of what we call light pollution. That means there's a lot of lights on at night. And when there's a lot of lights on, it's difficult to see objects that are very far away and are very, very dim. It's the same thing when the sun is up, right? When the sun is up, it's so bright we can't see any other stars. So in order to see stars a little bit more clearly, you have to go to someplace very, very dark. So there are designated dark sky parks in Michigan. I believe Michigan has 7 dark sky parks. Now the closest one to us here in Detroit is probably either Clayton or Port Austin. So there's a dark sky park in both of those cities. So if you guys wanted to go someplace very, very clear, very, very dark to see the sky, I'd recommend going either there or someplace nearby that's pretty far away from a lot of bright city lights. So someplace like a farm, for example, or a place that's not very urban. That's a good question.
A couple of weeks ago, we had a live event with the DNR, and I was thinking parks would probably be a good place to go see stars. Is that normally true if they're not close to a big city?
Exactly right. Yeah. So a park would be good as long as it's not close to any bright lights. So if it's close to a lot of, for example, street lights or a lot of traffic, parks can be kind of difficult. But any place that's sufficiently dark.
And then is there
in your way?
Is there a better time of year? Is it easier to see in the winter, the summer, or?
So when it comes to the different seasons, the only thing that really changes whether or not it's more clear or not is the weather. So if you have a clear night sky, that's probably the best chance to see it, no matter what season you're in. The thing that does change throughout the seasons, like I was saying earlier, are our seasonal constellations. So basically, if you go out someplace very, very dark in winter to look at the nighttime sky, you'll be seeing different seasonal constellations than what we talked about here today. But
there. Cool constellations every single season to visit. Hopefully, we'll actually be able to talk again sometimes too. Maybe during the fall, I can talk to you guys about some different fall time constellations that are up. I know my coworker's favorite time to view the nighttime sky is in the winter. The winter has some very, very cool constellations.
That's cool. Now, I know that you're from the Michigan Science Center, and this has been super helpful today to find stuff. Are there other things, other charts or anything that we could download that would help us?
That's a really good question, too. So there's a lot of different star maps that you can find online. And in fact, there's actually one that we're linked to here, I believe. So if you go to the website for your establishment, we send you guys a star map that people back home will actually be able to download and use it kind of as a guide when they're trying to find constellations on their own at night.
Oh, very cool. And the Michigan Science Center is opening back up pretty soon, isn't it?
Yes, we're trying to open back up in September. So hopefully we'll be seeing you guys in person very, very shortly.
Fingers crossed. All right, let's see what else you've got for us to do. What's your demonstration?
Okay, cool. So we're going to be looking at my studio now. So instead of being in our virtual planetarium, we're going to check things out right here. Now, I've been preparing a demonstration to talk a little bit about the vacuum of space. We've been talking about different things that we can see from here on Earth, looking up at the sky. We haven't talked very much about what it's like being in space in the first place. I mentioned that space is a vacuum. What that means is that there's nothing in space, not even air. So while we're here on Earth, we're surrounded by air. In fact, it's pressing down at us all the time. This is called air pressure. And there's about 14.7 pounds of air pressure pushing down on every square meter of your body. So we're going to do a quick demonstration and see what it would be like if we were suddenly placed in outer space. So I'm going to change my camera here so you get a little bit of a closer look as to what I've been working on. So over here, what I've been doing for a little bit now is I've been heating up some water in these cans. Might be a little bit difficult for you guys to see at home, but there's actually steam coming out of these cans right now. Why that is the water that's been placed inside of my can is being heated up and evaporated. So all of that liquid water is now turning into a gas. Gases fill the shape of its container. So right now, these cans aren't empty. They're actually full of gas. What I'm going to do next is I'm going to introduce these cans to my cold ice bath here. Now, if heating something up causes it to turn into a gas, when that gas gets cooled down again, that'll cause it to condense and reform into a liquid. What that means is that all of the gas that's been taking up the space inside of my can will suddenly be condensed to a very, very small space. Essentially, we will have created a vacuum. The can will go from being empty to full, or I should say, it'll go from being full to empty. All right, so give me a second to master using these tongs with one hand. Okay, fantastic. All right, so these seem sufficiently heated at this point. So I want all of us back home to pay close attention to what happens to my can when I introduce it to the cold ice bath. Are you guys ready?
Oh, we're so ready.
All right, so in 3, 2, 1. All right, so as soon as this was introduced to the cold ice bath, the can was immediately crushed. Basically, that vacuum inside of it couldn't withstand the pressure of 14.7 pounds pushing down on it from the air pressure. What does that mean when it comes to outer space? That means when we have to build things like rocket ships that take us to the moon or even further out, we have to make sure that they are made out of materials that can withstand the vacuum of space. All right, so that's actually the last thing that I have to show you guys today. Do you have any more questions for me about the can crush or any questions from the audience before I let you guys go?
Was there a second can that we could watch? We blipped with the Wi-Fi. We actually looked like a magic trick because you had the can here and then all of a sudden we saw the can crushed. Is it possible to do that again?
Yeah, absolutely. It does happen very, very quickly. But let's try that one more time, okay? That is actually why I have a second can here in the first place.
Awesome.
All right, cool. So let's see. This one, okay, pretty heated. This one should be good. So just like before, I am going to introduce my can to something cold. It'll go from being full to empty, simulating a vacuum. Let's see what happens in 3, 2, 1. Oh, no. Okay, this one didn't get quite hot enough to crush, unfortunately. Let's see.
Well, it froze
Yeah.
again, so freezing in a different way. It's tough to do alive in the middle of a storm, apparently.
Unfortunately, it's too bad. That first one crushed so well. I can let this heat up for a little bit more. It could potentially crush a little bit later, but we'd have to let it heat up a bit again.
Is there a safe way to do this experiment at home? I'm guessing that if you're a kid watching this, you should have an adult supervise you to do this, but that's just water in a can and you heated it up. Would that be something we could do on a stove?
Yeah, exactly. So this is definitely something that you should do with an adult and to make sure you don't touch it. Like, for example, you guys see that I'm using tongs. You would also wear some like safety gloves, some flame resistant gloves in addition to your tongs. But this is definitely something that I recommend doing with an adult. All you need to do is to have some hot water heated up, a can, and an ice bath. And that's how you can replicate this experiment at home.
We would love to see those of you watching. If you didn't get to see this, I'm assuming your view is just like mine. If you didn't get to see this at home, what you can do after this experiment, after this live, is grab an adult when they're ready and see if they'll help you. And then you can put little videos or pictures of how you did this at home right in the chats. We would love to see those and we could share them to our main page. So
yeah, exactly. And we'll actually going to post a video of us doing it as well on our Facebook.
Great.
So you guys can watch that and try to follow along with the instructions at home.
Excellent. Excellent. Well, thank you so much for your time today. This has been fantastic, an excellent way to end our 8 weeks of summer. We look forward to partnering in the future. And just to remind all of you watching, we may be done with our 8 weeks of summer with the Michigan Learning Channel, but we are not done learning because just like me, I went into the teaching field because I wanted to be a lifelong learner and I love fun ways to learn. So join us at michiganlearning.org. You can find lots of things there. We also, if you have a teacher or if you're a parent that aspires to teach your children, we have a very big day coming up, August 18th. We will be hosting a professional development, although if you're not a teacher, you can join us too to learn how to do this. Teachers will get sketches for this, which is something they look forward to getting, I believe. But August 18th, you can tune in. We will be going over the Michigan Learning Channel and how to use the resources as well. So join us August 18th. Go to michiganlearning.org. If you type in teacher resources right after that, it'll take you right to a calendar where you can find all the events we're doing. Or if you just want to go to michiganlearning.org, you'll be able to navigate stuff from there. So we've got the website down here on the bottom of our page, michiganlearning.org/teacher resources. You can find how to use the Michigan Learning Channel and any events that we will have going on in the state of Michigan, not just Detroit. We look forward to going back to school with you and supporting parents and teachers and kids as we do that. So thank you again to the Michigan Science Center for having us, and we will see you soon.
See you guys soon. Thanks for having me.